Hello, my dear students. Welcome back to the lecture. So, in this lecture, I'll teach you the concept of how to place the column, and with the same logic, you can use it whenever you try to place the column. Yeah. So now everywhere you can see the black color, right? All these are the column what I have placed. Okay. Now I'll give you this thing, the distance. The distance between these two columns is 5 meters. From this column to this column, it is 3.5. This is 4. This is 4.5, and this is 6.5. And then from this column to this column it is 4 meter. From this column to this column it is 6 meter, right? Now how shall we place the column? Now for this particular column, what I have two options. Either I can place my column like this, what they have shown it, or the second option is that, yeah, I can place it like this, what they have shown it. Otherwise I can keep my column in this direction also, right? I can keep it in this direction also. So which one to choose? Similarly, I have a column here, right? So I can place this column in this direction, or I can place this column even in this direction. So which one to choose? So usually what you need to see is that in whichever span the length is more, your depth of the column should be parallel to that. I'll repeat my statement. In whichever direction the length is more, your depth of the column should be parallel to that longer direction. To put it in a better way, now at this particular junction, this is a beam. Okay, what is the distance of this from this to this column to this column? This is my column to be considered. So this is 5 meter and this is 4 meter. Out of 5 meter and 4 meter, which is longer? Obviously 5 meter is longer. So what I'll be doing, this particular column, I have to place it in this direction. Got it? So then I told the depth of your column should be parallel to the longer dimension. That means what do you understand by that? That means this is the depth of my column. You can, if I take this as column, if this is my column, this is the breadth of my column, and this is the depth of my column. So this depth of the column should be parallel to the longer direction. So 5 meter is a longer direction, no? So this depth is parallel to the longer direction. Got it? So according to our logic, the column what they have placed in this direction, this is wrong. This is not how the column should be placed. The column should have been placed in this direction. Okay, got it? Good. Now come to this particular point. Now you tell me this particular column whether it is placed correctly or not. So whenever you have a column like this, now you need to see this for this particular column. This side it is 5 meter. For this particular column on the right side it is 3.5 meter, and from here to here it is 4 meter. Now you tell me which direction you need to place the column. So whenever you have the junction column, you need to, what you need to do, see, for this particular column, this particular beam, I'll go with a different color. So for this particular column, this is a column to be considered. For this particular column, this beam is pulling here, this beam is also pulling here, and this beam is also pulling here. Okay, so here what is happening for this column on this direction, this column is getting pulled by 5 meter. For this particular column on the right side, it is getting pulled by 3.5 meter. So what is the net pulling that is happening here? So 5 minus 3.5 is only 1.5. That means in this direction, it is getting pulled by 1.5 meter. That's it. But whereas in this direction, this is 4 meter. So that means 4 meter and 1.5 meter, which is greater? 4 meter is greater. So that is why this column placing is also wrong. This column should have been placed in this direction, like this. So that the depth of the column is parallel to the longer direction. So this is the depth of the column, and this is my longer direction. So it is placed in this direction. Getting my point? Yeah. Now we'll come to another column. I'll come to this particular column. Now you have to decide and tell me this particular column. Tell me whether this column is correct or not, whether the placement. So first let me draw the beam for that, just for understanding. This column is getting pulled in this direction by how much? This is 4 meter. This column is getting pulled in this direction by 6 meter. Similarly, this column is getting pulled in this direction by 4.5 meter. By 4.5 meter. This column is getting pulled in this direction by how much? 6.5 meter. Okay. If you want, I'll write it. So this is how much? This is 4 meter. This is why it's not coming. Okay, 4 meter. Now this is 6 meter. Then this is 4.5 meter, and this is 6.5 meter. 6 point 6.5 meter. Now we need to check the net pulling. That means for this particular column, it is getting pulled in 4 meter in this direction. It is getting pulled in 6 meter in this direction. So net is 6 minus 4. So the net pulling is 2 meter. Okay, I write 2 meter. So 6 minus 4, which is equal to 2 meter. This is the net pulling that is happening. So this column is getting pulled in this direction and by 2 meter. Similarly, this one, this is 6.5 and this is 4.5. So again, it is 2 meter. So again, it is 2 meter. Now now again, this one, 6.5 minus 4.5. So again, it is 2 meter. So in which direction? 2 meter in this direction. 2 meter in this direction. Now you are an engineer. You can decide whether now you have, see, here also it is 2 meter. Here also it is 2 meter. So both the axis it is same. Now whichever area you keep the depth, nothing change will happen. So now you can decide whether you want to keep it like this or whether you want to keep the dimension of the column in this direction. So it's up to you. You are an engineer in charge. You can decide. But when you decide such column, you need to check whether if I keep, now you see, now if I take it back, yeah, I'll keep it like this. Now if I keep a column like this particular portion, this extra portion is creating an offset in your room. So from aesthetic point of view, it will not look good. But this particular column is good because this column is not creating any offset in this room, nor this column is creating any offset in this room. That is from aesthetic point of view, this particular column is good. So I'll keep the orientation of this column in this direction. Getting an idea? So this is how the column location, column orientation should be decided. So first logic always, wherever is the depth, the larger the depth, the larger the dimension, that parallel to that you have to keep your depth. Sometime if your net moment is equal, then you have to decide whether you want to keep it vertical or horizontal. Based on the aesthetic point of view, you can decide. Sometime there is a situation where from your concept point of view, this column should be placed like this. For example, let us consider, I'll take one option. Okay, anyhow, I'll explain you from this thing, practical point of view. I'll take you one image. I hope these concepts are clear. So what I can do is, yeah, I'll give you some examples here. See here. These are a few examples we'll put on the live project and we'll check it. See here. So here you can see a lot of columns being placed, right? So if you look here, which column shall I take? Okay, anyhow, here nothing much difference can be seen. Okay, not this one. This is not required. Yeah, we can think of this image. See here. Now this will be good. So you have one column here, you have a second column here, and here you have another column. Now, how the orientation is decided? See, the depth of the beam is like this, isn't it? This is the depth, and inside portion is width. So if you consider this, so this length is more. This length is more in comparison to this length, right? This length is more in comparison to the inner depth, inner one. So this length is very less, but whereas this is larger. So that is why this is the depth of your column, right? So your depth of the column is parallel to the longer direction. Got it? So practically, this is how it is done. So again, I'll show you one more image. Yeah, this one is a better image. See here. So I have a column here. So for this particular column, there is one depth, or there is one beam in this direction, and there is another beam in this direction. Let us consider this particular beam. This particular beam is uh, 3 meter, and this particular beam is 5 meter. Okay. So in which direction you will keep the depth of your beam? So this is 3 meter, and this is 5 meter. Obviously, the depth of the beam is parallel to the 5 meter. So you can see this is the depth of the beam. This has been placed parallel to the 5 meter. Got it? That's the first thing. Now again, you see one more thing. Now look at this particular column. So let us consider this is let us say I'll say this as 3 meter. I'll go with a different color. Yeah. So this So let us say this particular beam what I have, that distance what I have, it is let us say 3 meter, or let us say 2.5 meter. And this one, the beam on this direction, it is let us say 5 meter. So what is the net? Net is 5 and 2.5. If you deduct, the net is 2.5, right? Net moment. And again, here there is only one beam in this direction. And let us say the length of this beam is 4 meter. Now you tell me from which area or which side your depth of the beam will be. This is 4 meter. I don't have a beam. Forget about this. This is not a beam. This is the additional thing what we did later. Imagine there is no beam in this direction. So this column is getting pulled by 4 meter in this direction, whereas this column is getting pulled by 5 meter in this direction and 2.5. That means the net is 2.5. So out of 2.5 and 4, which is more? 4 meter. That means the depth of the beam, the depth of the column should have been in this way. The column should have been like this, right? Actually, according to our logic. But what happened, you can see, still according to our logic, the depth should be somewhere like this. What they have done, the depth is parallel to the minor axis. Why is that so? That is from aesthetic point of view. See, the first reason is whatever logic I'm telling, that should be sufficient. I mean, that should, what do you call that? So that is the first reason. In second, you need to keep the aesthetic point of view also. Now, aesthetic in the sense, it's a parking area. So it's a car parking area what we have. Suppose if this column was placed like this, then what would have happened? This extra portion, no, this would have created a obstruction here. So the again what happened? These columns are like this. These columns are placed like this. The other column is also placed. Only this column is placed in this direction, which will not look good aesthetically. Second, it will create offset since it's a parking area. So even though the requirement was to be kept in this direction, we didn't keep it. So in this case, what will happen? The reinforcement requirement in this column will little bit change. That's it. Let us say you require 16 diameter 6 bar. If you had placed, you require 16 diameter 6 bar. If you had placed it like this, since you did not place it like this, you placed your column like this. Maybe now instead of 16 6, you may require a 16 diameter 8 bar. That's it. And nothing much change will happen. Got it? So that is why you need to take care of the column orientation. Got an idea how it has to be done? Yeah. Then after that, I think 2 3 things I've explained you. This is also done. Yeah. Then let me go with one practical image. So let us say this is one of the plan what I have. Now we'll try to place the column here. Okay. So quickly let me do that. So what again? Apply your logic. Corner I'll place one column. This corner I'll place another column. I'm randomly keeping. Okay. Then I'll keep one column here. I'll change the direction now. I'll keep one more column here. Finish. This is done. After that, what you can do? After that, you can think of keeping one column here. Like this, you can keep. Okay. So since there is a window coming, I actually what I can do is, yeah, this column and this column. Next, I'll keep one column somewhere here. I'll keep one column here. That is sufficient. Okay. Or I could have kept one column here. Here also I could have kept one column. And again, you need to check how it will look. But still, initially I'll go here. I'll keep one column here. That is sufficient. After that, next what I'll do is I'll place one more column here. Then what I can do is I can place one more column here. And I'll place one more column here. Good. Is that fine? I think that is sufficient. Yeah. Here also I require one column. So here I can keep a column dimension like this. Fine. So is it okay? Oh, I think 3 columns here, 3 columns here, 3 columns are here. That is sufficient. In future, if you feel there is a requirement of one more column, you can plan, you can plan to keep one more column somewhere here. Here, you can think of doing that. Okay, you can think of doing one column here. That also can be done. But right now, I'll go with only this much column. But now the main question is about the orientation, whether this orientation is correct or this orientation is correct. How do you decide that? So for that, what you need to do, you need to know the dimensions. Now dimension, how you'll measure it. See, this is 8 feet, okay? 8 feet. Then again, this is 3 feet. 8 plus 3 is 11. And this is 4.5 feet. So 8 plus 3 is 11. 11 plus 4 is 15. I'll say it's 15.5, but I'll go with 15. Actually, it's not 15.5. It's a 9 inch, and 9 inch you need to add. But roughly I'm going now. I'm thinking that the distance between this column, that is from here to here, the distance is how much? 8 plus 3 is 11. 11 plus 4 is 15. So this is 15 feet. 15 feet. Good. Now check what is the dimension from here. From here to here. Because I placed one column here. Next column I placed it here. How much is this? So this is 12 feet. How did I know it's 12 feet? See, this is 12 feet. No. So this is 12 feet. So this is 12 feet. Now you tell me, according to your logic, whether the column is properly placed or not. So from here to here it is 15 feet, and from here to here it is 12 feet. Out of 15 and 12, 15 is a longer direction. So the depth of my column should be parallel to the longer direction. So whatever placement I had done, this is correct. Suppose instead of this, suppose if yeah, suppose instead of this, let us say, initially I kept my column like this. Suppose instead of that, I had kept my column like this. Then it's a wrong orientation. Why? Because this is a shorter dimension, 12 feet. This is 15 feet. So the depth of my column should be the depth of my column should be parallel to the longer dimension. So that is why placing the column in this direction is always a right placing. Got it? First thing you understood. Next, what I'll do? Next, let me go for this. Let me go for this. This is also correct. There's no problem with this. Let me go with this. Shall we go with this particular column? See, all those who are able to understand, it's well and good. For someone who is not able to understand, that is fine. Because in future, I'll be taking a lot of drawings where I'll be explaining you all these things. But these are the initial ways how you can understand the placing of a column. So again, for this, let me start. So what is the distance? See, from this column to this column, it is how much? 10 feet. It is 10 feet. This is 10 feet. And from here to here, it is 9 feet. So out of 9 feet and 10 feet, out of 9 feet and 10 feet, which is greater? 10 feet is greater. So my depth of my column is always parallel to the 10 feet. So this orientation is also correct. Okay. So next what I can do is I can uh, almost everywhere the column is correct. I can think of this also. Let me think of this. Okay. The last one. So the distance between this point to this point is how much? 9 feet. Yeah. Now it will be interesting. And the distance from this column to this column, it is 12 feet. Okay. If you want, I'll write the distance between this column to this column, it is 9 feet. I'll write 9 here. And from distance between this column to this column is how much? 12 feet. Okay. Where it is mentioned, everything written here. 9, always horizontal. The first number is horizontal, I told you. The second number is vertical. So now tell me, out of 9 feet and 12 feet, which is bigger? 12 feet is bigger. That means this column location, what we have done is not correct. This column should have been located. This column is not correct. I'll delete it. And now I'll place the column in this direction. Like this. Now it is correct. I should have placed the column like this because this is 12 feet and the longer dimension of the column is parallel to the depth of the column is parallel to the longer direction. Got it? So whenever you place the column, randomly you place it. You don't think of whether 9 feet is bigger or 12 feet. First, you have to follow that clause. All the corners you will place the column. The distance between the column is not more than 4 to 6 meter or 12 to 18 feet. And all the column will come in the straight line. After that, you can, once that is done, next you think of changing the orientation of the column, whether it should be horizontal or vertical. In the initial stage, you shouldn't think of that. That is the second stage. Initial stage is just place the column randomly, whether horizontally or vertically, it's okay. Later you can decide it. Got it? So I explained you for the practical image also on this particular plan. Then also I explained you the concept of that. Now the last concept is that why the depth of the column should be placed along the longer dimension. That's the main question. So it's very simple. So I'll explain you that here. Where shall I explain you that? Yeah, I'll explain it here. Yeah, let me explain that here. Hmm. Yeah, so for that I'll take two images. This is one image and this is another image. And then I'll draw a beam to that. Connect that with the beam. Okay, the same thing I'll do it again. This is again another column. Then I'll take a beam. This is a beam. Then again column. Okay, so two cases I have taken. So what I have done, I have taken two cases. So this is case number 1. This is case number 1. If you want, I'll write it. Case 1, and this is case 2. Case 2. Yeah. Okay. So here, when the load comes on this beam, this is beam and these two are column. Okay. So when the load comes on this particular beam, what happens? This beam will try to bend. This beam will try to bend. So when it's try to bend, you can see this is the depth of the column. This is also depth of the column. The depth of the column will hold it. So it will not allow more bending in this direction. More bending of the beam will not happen because your longer depth of the column, you have placed it parallel to the this direction. Got it? Whereas here, if you see, when the load comes on the beam, when it tries to bend, you have only this much depth. Only this much depth, and this much depth is able to resist that bending. So, but whereas majority of your depth is going down, no, this is not. This is of no use. So only a small depth. You see, this is capital D. Okay. For example, I'll put it in a better way. What I'll do is I'll write the dimension also, so it will be easy now. So this dimension is 230. In that case, you'll be able to understand. This is 230, and this is 450 mm. And here, this is 230, and this is 450. Okay, now you understand. See, here you are trying to bend. So this 450 depth is there. So 450, and this also 450 will try to stop this bending. So that is the depth of the column is parallel to this direction. Okay. Whereas here, when the load comes on the beam, when it tries to bend, only 230 and this side 230 is there. Whereas the majority 450 is going down. Okay. So this orientation, the only 230 depth is there to take care of that. So that is the reason what we do usually. Whatever is the depth of your column, the depth of the column will be placed always parallel to the longer direction. Okay. Because ultimately the load carrying capacity of your beam or let us say this thing column, that will be depending on moment of inertia. Moment of inertia, MOI. Moment of inertia is how much? BD cube by 12. Okay. So the moment carrying capacity of is BD cube by 12. So you see here the breadth is 450. Sorry, here the breadth is 230 and depth is 450. And here the breadth is how much? The breadth is 450 and the depth is 230. You are able to understand here 450 depth is there to take care of your load. Here only 230 is there. So if I put the moment of inertia here, it will be how much? The moment of inertia, it will be how much? BD cube by 12. So 230 into 450 cube. 450 cube. I'll write cube like this, okay? Or I can write like this. Where is that? I'll write like this only. 450 cube by 12. If you do, you'll get a big answer there. But whereas here the moment of inertia is how much? What is B? B is your 450. This is breadth 450 into what is the depth? Depth is only 230. So 230 cube by 12. Now you tell me, if you get an answer, this answer will be higher than this answer, no? So only less depth is available here to take care of that bending. But here larger depth is available to take care of the bending. So always remember the depth of the column will be parallel to the longer axis. I mean, depth of the column will be parallel to the longer direction. Okay, because of the moment of inertia, because it is always a D cube. So D is depth is larger, no? Here depth is small. So 450 cube is bigger or 230 cube is bigger? Obviously 450 cube is bigger. So more moment of inertia is there. The load carrying capacity also will increase here. Okay, simple. This was the logic behind all those things. That is why whenever we place the column in the AutoCAD or maybe in anything, always try to understand the concept. And this is how the this is how the column location and the column orientation should be decided. Got it? Yeah. So I hope you have enjoyed my lecture up to here. You got a complete idea like how the location of the column will be decided and all those things. Anyhow, what I'll do is I'll give you this particular drawing. Yeah, take this particular drawing. Okay, and you need to decide, you need to place the column. Anyhow the column is placed, you can delete the column and you place the column according to your own and check how you can think of placing the column. Got it? Yeah. So we'll see you back in the next lecture. Thank you.